Hey everybody, Bill Sky, the COBOL guy, and we're back with another video on defining data in your COBOL program. Now, if you haven't watched the previous video, which was Introduction to Defining Your Data, I believe it was video number 3. You definitely want to go back and take a look at that. What this video is doing is that we're going to be talking about different types of data types that you can define in COBOL that are really meant to do arithmetic calculations. The previous one was just basically ASCII values. If you remember in our program in video number 3, we did a lot of pick 9999, V99, things like that. Those are actually ASCII valued variables, and even though you can do math on them, they're still not efficient for doing math. You need to use computational data types in COBOL to actually have efficient, fast-running programs. Now, why do they have such things? Why do they have 9999, V99, and things like that to represent numbers when you can do math on those? Well, the reason is because you need to be able to format data in a really good way to display on a business report, like a accounts receivable report or an order report. You can't have the decimal point everywhere. So those variables are very useful for that. Computational variables and binary variables, those are useful for heavy math. You can always copy them over to a 9x variable for printing, but for computation, it's really best to use the computational or binary variable data types that we're going to talk about today. So let's jump into it. All right, so I'm on Linux once again just because of the ease of use, and I'm going to go into my documents and I'm going to make a new folder. I'm going to call this one let's call this one usage examples, and you'll see why I call it useful examples in just a moment. And I'm going to create a new COBOL template and name it main, and I'm going to bring it up. Now again, if you don't know how I did that COBOL template, it might not be a bad idea for you to take a look at the previous video. Actually, I believe it's video number 1 on setting up a template. It might be video number 2. Yeah, I think it's video number 2, your first program. So anyway, so here we go. So I've got my template up here and running. Now a couple of things I do want to show you. I'm in the Genie editor, and over here we've got all of our different numbers. I came up with a way to renumber your COBOL program automatically. So let's say if we go down here, and I'm going to go down to the procedure division, I'm going to add a new line of code. So I'm going to go ahead and name that, and I would like to build it. Now within the Genie editor, there's actually a terminal option. Down here on the bottom, you've got a number of different little tabs. There's actually a terminal. I'm going to right click on that, and I'm going to say set path from documents. So what that does is it moves me into the directory where my COBOL program is located. And I'm just going to go ahead and compile this. Is it COB? Let me see. Yep, it's COB. And I can actually build it from within the Genie editor terminal. And then I'm going to go ahead and run it. Okay, great. Program ending. Have a nice day. The purpose of this demonstration, though, other than to show you this where you don't have to open up your own terminal, is that we are missing a number. And really, to make that line number, I'm going to make it 002900. Well, the problem with that is that I have 29 down here already. So it would be really nice. I wish Genie had this capability, but it would be really nice if Genie had the ability to renumber your program lines. And I do have a way to do that at the top, and I'll put this in the description of the video. At the top right here, I have this little aux script. And what I'm going to do is I'm going to copy that. I'm going to paste it, and I'm going to change the name of my COBOL program to main and press enter. And what awk is it's a way of reformatting your data. It's AWK. You need to take a look at it if you don't know what it is. It's really useful. And let me go and display my Documents tab up here in Genie. I'm going to right click on this. Now notice down here we've got blanks in the line number. I'm going to right click on this and say reload, and boom. So what awk did was awk actually went through and renumbered all of my code, so I don't have to do it manually anymore. That is such a cool feature. And you do have to put in the first line number to give awk an idea of where you want to start with your numbering. But it's a really nice feature. Now, other editors like ISPF on the mainframe, SPF PC, which is a DOS-based or Windows-based editor that you can get, which will do this automatically. It'll automatically renumber your lines. But this is a way if you don't want to use those, if you don't want to buy them, you don't want to, you don't have access to a mainframe, or you don't want to set one up on your own computer, which I hope to get to in this course. This is a good way to do it, is with awk. So you do have to rebuild it after you reformat it, and then the program works. So I just wanted to show you that new feature. It's really, well, it's not a new feature, but it's a feature I came up with. It's really nice. And by the way, I will also put this COBOL template up as a link in the description of the video. Okay, so let's talk about what I was saying earlier. If you notice right here on line 20 of the Genie editor, we kind of have what we were doing in the last video, where we're just creating a set of bytes, in this case 4 bytes, that are supposed to hold numeric data. Now those 4 bytes are actually ASCII bytes. Now if you don't know what an ASCII is the heart of computers. I would say PCs, personal computers, Macs. On mainframes it's different. It's EBCDIC, there's other there's other how should I say it, character display languages or types out there. EBCDIC is something that IBM used. But if we take a look, if we go to ASCIItable.com, you can see what the ASCII table is. Now, the ASCII table is simply a way to translate a number, a hexadecimal or binary number that's stored in the computer, into something that can be displayed on the screen. The computer doesn't know anything about characters. It doesn't know anything. All it knows about are numbers. So it might look like the computer is able to store strings and characters, but it actually isn't. It's all numbers. And you have to have a way of presenting those numbers in a character fashion to the user, and on reports, and everything you see on the internet is that way, or in computers. And that's using the ASCII table, the ASCII character set. And if you notice over here, we've got the decimal column, the hexadecimal, the octal. We even have the HTML number that you would use if you're going to be displaying that character on a web page. And so, for instance, the number 1, 2, 3, 4 is actually the number 49, 50, 51, 52. So the number 1, 2, 3, 4 actually takes up 4 bytes. Now the number 1, 2, 3, 4 can actually be stored in a single byte as a binary piece of data that you do math on. But 1, 2, 3, 4, can 1, 2, 3, 4 be stored in a single byte? It might be 2 bytes. But 1, 2, 3, 4 in ASCII takes 4 bytes, because each byte is an ASCII character. Now in assembler language at the machine code, you really can't do math on that until you convert it to binary, then you do the math, then you have to convert it back to ASCII. So ASCII is really nice because it translates, it allows you to translate a number into something that the user can understand, but it's not something that you want to do math on. Now in COBOL, you can do math on this, in this case WS counter, you can do math on that, but the way that it works is that it converts it to binary, it does the math, and then reconverts it back to ASCII. And if you think about it, that takes up a lot of processing time. So if you're trying to create a program that's running faster, you definitely don't want to use this. So there's a keyword we can make, and I'm going to do my first one here. And we're going to call this one comp1 variable. Let's just keep it. And what I'm going to do here, I'm going to say usage comp1. Now comp1 also means computational one, or just computational. And that means that that piece of data, in this case comp1 var, that is actually a floating point number. So let's get into the different types, and then we'll do a bunch of examples of it. So the first one I want to talk about is not computational. The first one I want to talk about is binary. So I'm going to come back here and I'm going to say binary var1. And we're not going to give it a pick. We're just going to say, well, actually, in this case, we are going to give it a pick. We're going to say pick 9999 usage is binary. Now, binary is going to store the number into memory as a binary number, but it depends upon the number of characters that you specify in the pick, in this case 4. So in the case of this one, 1 to 4 bytes will be stored as a 2-byte integer. And I'm making these comments. 5 to 9 bytes, or I should say 9s in this case, that's going to be a 4-byte integer. And 10 to 18, and let's change this to 9s. It really should be 9s. That's going to be an 8-byte integer. Okay, kind of confusing, but it does it for you. So if you create this one right here, this will only be a 2-byte integer. If I add another 9 here, it'll be a 4-byte integer because it needs that many bytes to actually store the data. And if you create a whole bunch more up to 18, it'll be a 9-byte. So that's what binary is, and it'll actually be stored in memory that way. So no problem. If you want to do all of your data as binary, that's fine. You can actually do it as binary. In this case, it's 4 9, so it'll be a 2-byte integer. And there's other ones. Let's go ahead and create a comp var1. And in the case of comp var1 or comp is a different type of numeric data. It's just represented a little bit differently. It actually is the same as a binary. So a comp binary. So if I say usage is comp, and let's go ahead and save and build this. And if you notice because it's the same as binary, let's take away the pick. It's good that we did that. We made that mistake, and let's try it out. You can see that for binary and comp, and we're using GNU COBOL, it's the same on IBM COBOL. You need a pick because it needs to know how big it is. So I'm going to go ahead and put a pick there. Now I'm going to put a pick here because the error says it, 1, 2, 3, 4, 5, and say usage is comp, and we're going to go ahead and save it and build it, and it builds fine. Let's go ahead and awk it. Let's reload it. And now we've got our line numbers. Okay, so comp is the same as binary. Okay, let's do another one. We're going to say comp1 var. And on this one, we're not going to say pick 999. We're going to say usage is comp -1 and press enter, save and build it. And it builds fine. So comp1 is our first floating point number. And let's put a comment in there. Comp1 is single precision floating point. I guess it's the same in C and C++ as a float in C and C++. So it's a single precision floating point. Let's do another one. Comp2 var. Usage is comp2. And you could also write out computational completely. And that comp2 is a double precision floating point, and that would be the same as a double. So let's save that. Let's go ahead and awk it, reload it. There it is, cool. And now let's build it. and it runs just fine. We're not doing anything with the data yet. So that's a comp2. Now again, why are we going through all this is because we are specifying numbers or variables that we want to do actual math on it in an efficient way. Now another reason why you might want to do this is because if you're going to be communicating with other programming language object files like C or C++, I believe Fortran is the same way, you have to specify a native CPU numeric data type, like a float, a double, a quad, things like that. Okay, so that's comp1 and comp2. There's another one, and let me go ahead and copy this comment. There's another one called binary packed decimal var, and I'm going to say usage is comp3. And let's go ahead and save and build that. Make sure Now for comp3, you also need a pick, as you can see by the error. So I'm going to say pick 9999, save and build it. Actually, let's awk it, and then let's build it, and it builds just fine, and then let's reload it. Okay, so what is binary packed decimal, or packed decimal, I should say? And let's actually change it to just packed p decimal. Packed decimal is a really interesting data format, and I personally have not used it since I've been off the mainframe. Let's do a little bit of drawing here. So what a packed decimal number is, first of all, let's take a look at a byte. So what we have here is we have a byte, and this byte is represented or consists of 8 bits. A byte divided by 2 or halved is 2 4-bit what they call nibbles. Packed decimal format means that there's a decimal number in each nibble. So the decimal digit is 0 through 9. You won't have any hexadecimal A's, B's, C, D's, E's, or F's. It'll be a decimal value of 0 to 9, and it'll be packed. So as you see in this one right here, we have the number 0123. That number 0123 is stored in 2 packed decimal, or I should say just packed decimal bytes. And it can be used for, gee, I don't even remember what I used packed decimal for, but it is available on COBOL, both on GNU COBOL as well as IBM COBOL. So that's a comp3. Another way of doing packed decimal is to actually use the keyword packed decimal. So I could, instead of comp3, I could have said packed, let's actually do that, packed decimal. And if I save and build that, it builds just fine. So again, on PCs, Linux computers, workstations, things like that, I don't use a lot of packed decimal. However, it doesn't mean it isn't used. It doesn't mean that functions don't require it as arguments going into it. So you actually might have a need to do that, and that's how you would do it. Okay, and there's also a comp4, but that's the same as binary. That's the same as comp. So that's what that usage is all about. Now there is one other one called display. So let's say if I wanted to create, I gotta fix my tabs a little bit here. Okay, so there's another one called display. Display is basically the same as a pick 9999 with a value 0 like we have up here on line 20 or line 2000. And that simply means that it's used for display purposes. And so what I could do is I could create another variable here called display var. I could say pick 9999 usage is display. And it's really not necessary if you're just going to say pick 9999 without any other usage. It really isn't necessary. Let's go ahead and build that, and it builds just fine. So that's kind of the default. If you don't say usage anything else, the default will be usage is display. So in the case of this one again, my WS counter, that is by default a usage is display. So why do you want to do this? Again, the usage is display, or the default for a pick9 variable is all the bytes are ASCII. That means that when you need to do arithmetic on them, the ASCII values need to be converted to binary. And in assembler language, there are quick ways of doing that, but it still takes time. It still takes more effort on the CPU's part, so it's not as efficient. So if you'll be doing a lot of arithmetic on a variable before displaying it to the user, or something into a file, saving it into a file perhaps, it's better to use binary or comp n, comp 1, comp 2, whatever, until the final value has been calculated, and then you can display it to the user if that's the case. Also, as I said earlier, these comp values or these comp variables may be necessary for other functions that you might be calling. Okay, now if you're interested in how big each one of these are, there's a really neat little function called length of. So I'm going to create a display here. The length of WS counter is, and I'm going to say length of WS counter. So that's kind of neat. So let's go ahead and save that. Let's awk it so we can get our line numbers right. Okay, and now let's build it. And it looks like we have a little problem here. Let me see. Oh, I didn't type it in. WS. Oh, I'm really glad this happened. Take a look right here. The COBOL compiler doesn't let you go past line 72. So it says it doesn't know what WSCOUN is because it chopped it off. And if you notice right here, there's a very dim line here showing you the end of your code. So what I'm going to do is I'm going to move everything over a little bit. Okay. The other thing I could do is I could press enter right here, space over to column 7, put a dash, continuation, and there we go. So we've also created a continuation line. Let's awk that, reload it, and you can see right there, and then let's build it. Now, the GNU compiler gives you an interesting warning, continuation of COBOL words used. I'm not sure what that means. I've looked in the user's guide. I haven't been able to find it. That doesn't mean it doesn't exist, but it doesn't really cause a problem. So it actually, the COBC actually worked this time. And I'm going to go ahead and run my program. So here we go. So length of says that the length of WS counter is 4. Why is the length of WS counter 4? Is because I said pick 9999, and that's 4 ASCII values. Now let's take a look at the length of binary var1. So I'm going to go ahead and copy and paste these two lines right here. And I'm going to say binary var1. We're going to go ahead and put that for our actual code. Okay, let's awk this. Don't forget to save before you awk it. We're going to reload it. And then I'm going to build it. So now because we have a continuation character, it gives me 2 warnings. Let's run it. Whoa, so look. So let's take a look here. So the length of for WS counter was 4 because it had 4 9s in the pick. That meant 4 ASCII values. But notice that the length of binary var1 is only 2. Why? Because it's binary. We specified 4 binary digits, and that can be stored in 2 bytes. And that binary value can actually be used efficiently for calculations. Okay, so comp is basically the same as binary, so we're not going to bother with that. I mean, we could. Let's go ahead and do that. So that is called comp var. So I'm going to copy this, and let's call this comp var. save and awk it. Let's build it. Let's run it. And now you can see the length of comp var is 4. Why is that one 4? Because remember our rules, 5 to 9 nines will give you a 4-byte integer. And there's your 4-byte integer. You can also specify that it should be a signed integer. And to do that, I could put an S in front and say that this will be a signed integer. So let's go ahead and build that again, run it. And it's still 4, but it is now a signed integer. So if I printed it, it would be a signed integer. Okay, let's take a look at the other ones. Comp1. So I'm going to copy this. And we're going to call this one comp1 var. Thank goodness for copy and paste. Let's save it. Let's awk it. Let's compile it, and let's run it. So a comp1 is 4 as well, 4 bytes long, but it is a single precision floating point number. That's what a comp1 is. A comp2 is a double precision, so it should be 8 bytes. So let's go ahead and do comp2. I believe it was comp var 2. Okay, we save it. Let's go ahead and awk it. Let's compile it. Let's run it. And you, oh, well, what did we do here? So let's see. So comp2, let me make sure I got my notes. Okay. So a comp2 is a double precision floating point. Double, it should be 4. I should be 8. I'm wondering why. Comp1 var 2. Did I get it right? Oh, I have the same value here. So it shouldn't be comp1 var. It should be comp2 var. Yeah, I've got my variable names wrong. There we go. So let's go ahead and save it. Let's awk it. I keep forgetting to reload my source code, so I'm getting these overwrite questions. And there we go. So a comp2 variable is going to be 8 bytes. Why? Because that is a double precision floating point. Packed decimal, let's take a look at the size of this packed decimal. Now, if you remember, I said that a packed decimal, every nibble, every 4 bits represents an actual decimal value. So let's see. I haven't done this for a while. Let's take a look. I think in this case, the packed decimal should be 2 bytes because we have 4 decimal digits, pick 9999, divide that by 2, and we get 2. So let's go ahead and, to make sure that we have the variable names correct and I don't mess up again, let's awk it, reload it, let's compile it, and let's run it. And oh, in this case, the length of the packed decimal var, p decimal var, is 3. Not really sure why that's the case. It might have something to do with the sign. I'm not really sure. Let's see what happens if we change it to an S. We add a sign to the beginning. Let's compile it. And it's still 3. So yeah, I'd have to do a little investigation as to why that is showing as 3. But notice it's not showing as 4. It's showing as less than 4. So it's actually, the data is all packed together. And our display variable right here, we really don't have to do a display on that or a length of on that because we know that each one of these is an ASCII byte, and that means that that will be 4 bytes long. You can go ahead and do that if you'd like to take a look. Okay, so this is by no means a comprehensive list of data types in either the IBM or GNU COBOL compilers. You need to look at the supporting data types, the supported data types in each of the user's guides or the programmer's guides. And let me show you really quick how to find those. All right, so I'm back here in Linux. Let's go ahead and let's go to the internet. Let's go back to our ASCII table. And what I'm going to do here is I'm going to search for GNU COBOL Programmer's Guide. And it should take me to the GNU COBOL website. It's taking me to the source, that's fine, the SourceForge. And there we go. So now this is 2.2. That's kind of old. Let's go to the GNU COBOL guides. And you can see the programmer's guide right here, 3.2. I'm going to click on that. And what I'm going to do here is I'm going to look for, I'm actually going to download this because I think the viewer on Linux is better. So I'm going to download this then on the web browser. And now I'm going to go to my downloads, and there's the programmer's guide, and I'm going to do a search. And I'm going to just do a search for comp1. And let's take a look at what we've got. Let's do a usage. Let's do a search for usage. Usage as. And let's see, it might be in the data division. Let's just do a bunch of find next. In the IBM manual, it's really, really easy to find. Let's expand the data division, working storage section. Let's see if they have anything about usage as here. Yep, or usage is. There it is, usage is. So let's change that to is. Okay, so I actually found the usage clause statement, and it does go through all the different types. If you notice, GNU COBOL also has binary, long, unsigned. It has computational, and it tells you what they are. So it's a good idea to download those. Don't be shy to download those files. What would I download? I would probably download the programmer's guide, the quick reference, and the sample programs. Now, if you're brand new to COBOL, the sample programs might be a little bit complicated for you, but you know, it's a good challenge. Okay, let's go ahead and do IBM. So IBM COBOL documentation in this case. And you can use the Enterprise COBOL documentation library, no problem. You're not using the x86 COBOL documentation is going to be a little bit different, but it's probably not a bad idea for you to use the Enterprise because that's really where most of the COBOL is done, not on the PC. So I'm going to click on product documentation, and you can see the language reference, the programmer's guide. Now the programmer's guide for IBM COBOL is different than GNU COBOL because they don't have really that much syntax in there. They have methods and ways of doing things. However, the language reference is quite useful. So I'm going to download that. And then let's take a look at that in our PDF viewer. And I'm going to Control F. I'm going to look for usage is. So it's called the usage clause. So you can see all the different ones that they have for IBM COBOL. Some of them are different, or I should say GNU COBOL has some additional ones, but you can see what they all are, and then you can just page down, take a look at them. When it comes to IBM documentation, this is actually pretty good documentation. I'm actually pretty impressed with this as I was going through this the other day. So you can see all the different types of usage is features within that compiler. One last thing, let's take a look and see if we can find the documentation for the IBM COBOL x86. So let's go back and do a search. IBM COBOL x86 documentation, and we get the COBOL for Linux x86 documentation library. It's going to take a little bit. This is a little bit snazzier of a website, so it's going to take a little bit longer to download. And you're going to have to click on a button, I believe, if I'm not incorrect, saying, oh, here it is right here. So let's see. So we've got the installation guide, the programming guide, the language reference. So we're going to go ahead and click on that. And the x86 version of IBM COBOL is a lot different than the enterprise version. There's a lot of things like the screen section and the report section are not included with the x86. However, I have to give it to the GNU COBOL developers. They included the screen section and the report section, which is why we're using it. And you're going to see what that is when we do a video on that. So you'll be able to find the usage is clause in there as well. All right, so that is more data definition in COBOL for both GNU and IBM COBOL. You need to know these to be able to pass parameters or arguments to non-COBOL functions, maybe even some COBOL functions may be requiring those. And we're actually going to do that in this course as well. So I think the next thing we're going to do, the next video is going to be on arrays, maybe redefinition. Hope to see you at the next video.